Number 1. The river that cooks humans. Andres Russo stood on the bank of a river in the Peruvian Amazon, steam rising off the water in front of him. His guide told him not to get close. Frogs that fell in didn't drown. They cooked, eyes turning white before the rest of their body even went under. Russo had heard about this place as a kid, stories from his grandfather about a river so hot it could kill you, and he never believed it was real. Locals called it Shanai Timpishka, boiled by the heat of the sun, and believed it was born from a giant serpent spirit living underneath, birthing hot water into the jungle. Scientists who'd heard rumors of it assumed the same basic thing, just without the serpent. That a river this hot had to be sitting on top of a volcano because that's the only way geothermal water gets powerful enough to boil. Russo checked the temperature himself, 210 degrees Fahrenheit in a stretch running 4 miles long and 16 feet deep in places. Then he checked the map. The nearest active volcano was over 400 miles away. No magma chamber anywhere near the river. No known geological feature that should be capable of producing that kind of heat. For a while, the river didn't make sense to the people studying it. What Russo eventually confirmed was that the river doesn't need a volcano at all. Rainwater falling in the Andes seeps deep underground and travels along a fault line, where it gets superheated by the Earth's own geothermal gradient, heat that exists everywhere underground. Number 2. It rained blood for 2 months. A loud boom cracked over Kerala, India, on July 25, 2001, followed by a flash in the sky. Then it started raining red. Not pink, red like blood soaking into people's clothes on the street. Locals watched it happen again the next day, and the next, and kept watching it happen for 2 straight months. Some were convinced it was a warning, a biblical sign written into the sky. Others were sure a meteor had exploded overhead and rained debris down with the storm. Wells that had been dry for years suddenly filled overnight. Trees dropped their leaves like they'd been scorched by fire. Scientists moved in to figure out what was actually falling. When they tested the rainwater, they found 9 million red particles in every single milliliter. Scaled across the entire 2-month event, an estimated 50,000 kilograms of red particles had come down over Kerala. That ruled out a small, localized source. Whatever this was, it had gotten into the atmosphere in enormous quantities. The official government investigation eventually traced the color back to something much more ordinary than a meteor or an omen. Airborne spores from a local algae called Trentipolia, which coats trees, rocks, and lamp posts across the region in a thin orange layer most people never notice. Under the right wind conditions, those spores got swept miles up into the clouds and washed back down as red rain. Case closed officially. Number 3. Earth has a heartbeat. For decades, geologists treated Earth's worst disasters as unrelated accidents. Mass extinctions, catastrophic volcanic eruptions, asteroid strikes, each one scattered randomly across hundreds of millions of years, connected by nothing but bad timing. That was the assumption baked into most geology textbooks. Catastrophe is chaos, and chaos doesn't have a pattern. Then a group of researchers went back through the geologic record and plotted the exact timing of every major catastrophic event they could date. What came out of the data wasn't chaos. It was a rhythm. Disasters weren't scattered evenly at all. They clustered together in bursts, roughly every 27.5 million years, again and again, stretching back over 260 million years. Run the math on how often that pattern should occur by pure chance, and it barely holds up. Something is timing these events, and it's been running long before humans existed to notice. Nobody has confirmed exactly what's driving it. One theory points outward, toward deep pulses of activity inside Earth's own mantle that resurface on a fixed timer. Neither has been proven. What has been confirmed, across multiple independent studies using different dating methods, is the timing itself. This planet appears to be running on a beat, and everything that's ever lived on it has been living inside that rhythm without knowing it. Number 4. Where does water come from? In 2021, a meteorite tore through the roof of a driveway in a quiet English town, and scientists rushed to collect the fragments before rain could wash away the evidence. Most people would assume water is just an obvious feature of Earth. Of course, a planet covered in oceans has water, the same way it has land, except early Earth should have been bone dry. The young planet ran hot enough, over 3,600 degrees Fahrenheit, to boil away any surface water on contact, which means whatever oceans exist now had to arrive or form after the planet cooled. For decades, the leading theory was comets, icy objects from the outer solar system slamming into a young Earth and depositing water on impact. Then, spacecraft got close enough to measure a comet's water directly, and the chemistry didn't match Earth's oceans at all. So the leading theory shifted to asteroids, which carry water locked inside their minerals instead of as ice, which is exactly what that driveway meteorite in England turned out to be. That theory holds up better, but it still doesn't fully account for the numbers. Now, some researchers think part of Earth's water was never delivered by anything at all, that it may have formed here, generated by hydrogen reacting deep inside an ocean of molten rock while the planet itself was still coming together. Three competing explanations, decades of research, and still no single agreed upon answer. The water in the ocean outside your window, the water inside your own body right now, might have crossed the solar system to get here. Number 5. Earth once looked like Saturn. Geologists studying rock layers laid down roughly 466 million years ago expected to find the usual scattered record of ancient meteor strikes, random impacts spread out unevenly, the way space debris normally hits a planet. Instead, they found something that didn't fit that pattern at all. A massive spike in meteor craters worldwide, and all of them clustered in a narrow band close to the equator, all dating to the same window of geologic time. Random impacts don't organize themselves geographically like that. That kind of clustering only forms one way: material falling from a specific, repeating orbital path circling the planet, rather than random rocks arriving from every direction. The leading explanation is that an asteroid drifted too close to Earth, got torn apart by the planet's own gravity, and scattered into a ring of debris that circled the equator, possibly for millions of years, slowly raining fragments down as it decayed. For a stretch of geologic history most people have never heard of, Earth may have genuinely looked like Saturn from space, wearing a ring of its own before it fell apart and disappeared from the record entirely. Number 6. We've only discovered 10% of our ocean. A research submersible drops 6 miles down into total darkness, past the point sunlight has ever reached, into pressure that would crush an unprotected human instantly. Most people assume that by now, science has already found and cataloged nearly everything alive on Earth. Centuries of biology should have covered the basics. And then the submersible's lights hit something moving that matches nothing on record. Entire colonies of organisms living off methane instead of sunlight, running on chemistry instead of light, thriving in conditions that should be lethal to anything. It happens almost every single time an expedition manages to reach new depths. Researchers estimate that more than 90% of marine species have never been formally identified or classified. Not obscure or rare species, the majority of everything living in the ocean. Entire hidden ecosystems are surviving in the deepest, coldest, most crushing parts of this planet discovered by accident, one submersible dive at a time. We are sharing Earth right now with a biosphere we haven't finished meeting. Number 7. The place that hasn't seen rain for over 2 million years. Say the word Antarctica, and most people picture the same thing. Endless snow, ice sheets stretching to the horizon, a continent buried in white. Tucked inside the continent, though, are the McMurdo Dry Valleys. Nearly 2,000 square miles of exposed rock and dirt with almost no ice at all. The largest ice-free region on the entire continent. The Transantarctic Mountains block moist ocean air from ever reaching the valleys, acting like a wall. On top of that, katabatic winds, cold, dense air rushing downhill off the polar plateau at speeds up to 200 miles per hour, scour away whatever humidity manages to slip through before it can settle. The result? No significant rain or snow for an estimated 2 million years, making the valleys both the driest and coldest desert on Earth, drier even than Chile's Atacama Desert. It's so barren and alien that NASA uses the valleys to test equipment built for Mars missions, and the only life scientists have found there survives in tiny pockets of moisture hiding underneath rocks. Number 8. We know more about Mars than our own ocean. Ask NASA for a map of the surface of Mars, a planet 140 million miles away, and they can hand you one detailed enough to plan a rover's exact route around individual rocks the size of a dinner plate. Most people assume Earth itself must already be mapped to at least that level of detail. Satellites circle the planet constantly. Every street on the surface shows up on a phone. Ask for that same resolution on Earth's own ocean floor, sitting a few miles beneath ships that cross it every single day, and it simply doesn't exist. Only a small fraction of the seafloor has ever been mapped to a comparable standard. The reason isn't that the ocean is unreachable, it's that reaching it is a completely different kind of hard. Mapping the seafloor means surviving crushing pressure, freezing temperatures, and total darkness using equipment engineered to withstand conditions that would destroy most machines. A space telescope, by comparison, can photograph an entire planet from a comfortable, harmless distance in orbit.